This is another friend working together with me in this project, and her name is Sandy, and both of us also is from the same university and same country. And this slide will show you the agenda for today's talk. First, I go through the introduction of the Emulator+Disassembler. Second is the design of the toolkit. The third is a toolkit design regarding the heuristic engine plus the wireless signature database. I go through how to design the wireless signature database and how to combine together, working together with the heuristic engine. And then continue with the emulator engine. This is a very interesting part. I will mix together with the disassembler. This design actually aims to the attack the metamorphic and polymorphic viruses. And then the next is the demonstration. Last is my next friend regarding this project. Okay, the first introduction. I believe everyone is know what is a malware, especially for those who work in malware reverse engineering. No matter how even your job is an exploit developer, you still need to know what is malware. Because nowadays, the exploiter use the exploit to execute the payload. They not so use a cell code in the payload. Now they are starting to use the malware. Malware can stand for the bot, or maybe the some Trojan code, and it is very effective. You can direct use the exploit to execute the payload and direct install the CNC client into your mobile, even the mobile handphone, your PC, or your laptop, and that's it. They can fully control and compromise your PC. So, from Wikipedia, malware stands for the malicious software. It's program. It's script code designed to disrupt or deny operation, gather information that lead to loss of privacy of exploitation, gain unauthorized access to system resources, or fully compromise the system. And now, I'll go through the concept of the disassembly. What is disassembly? Disassembly actually is a process or procedure to transfer the machine code. Machine code is 01011 because the machine just read the binary code. But normally we call it this is an opcode or mnemonic code. And this assembly is a process to transfer the binary code to readable, to human readable form. This is in assembly language. Tools using in this process is called disassembler, such as ImageBase, GDP, debugger. If you are malware user or exploit researcher, you should know ImageBase is a very famous disassembler on Windows and Mac OS. And it's very famous in static code analysis. And another one is debugger, WinDebug, and OnlyDebug. Emulator debugger and OnlyDebug actually is the same. They are using the same engine. But Emulator debugger is more powerful because it can combine together with Python. If you know how to write a Python, you can attach this process, and you can use the Python script to control the debugger. And from there, you can doing the fudging technique, fudging testing, and from there, you can doing some kind of malware reversing job or exploit research job. And this is an example of the process disassembly. As you can see in the picture, the binary code 101100 is converted to hexadecimal format equal to 0x58. This is here not in a human readable format, but this example can help us to convert the binary code direct to assembly code. For example, the above binary code is converted to the pop EAX. Pop EAX in assembly language is stand for pop the value from the current stack. So now is the question, how this assembler work? This definition is grabbed from the Wikipedia. This assembler is the software implementation of the CPU instruction decoder, and read the binary code and decode it as a stream of instruction in assembly language. And the third is prefix instruction of code, MODRN/SID, immediate data, blah blah blah. This is the actual instruction tables. You can refer the detail of this MODRN/SID or prefix from the Intel Software Developer Manual. It's a free and available download from Intel website. So, how this assembler help the malware analyst or exploiter in the reverse engineering process? The first, binary code more readable this is in assembly language form. Second is, this assembler provides the flowchart of the malware code to analysts. This indirectly speed up the analysis process. And the third is, this assembler also can use for breaking algorithm, encryption algorithm, creating signature and others. So this is example of flowchart generate use IDA Pro. As you can see, every block of code split to input and output. Input such as from others code segment, and the output could be false or true. This flowchart helping the analyst in reverse engineering process such as tracking the code flow, spot the interesting routine of the code, but not wasting the time to analyze the redundant block of the code. Now let me go through another concept of today's talk, emulator. From Wikipedia, the emulator is computing duplicate the function of one system using a different system, so that the second system behave like the first system. So in the market now, actually is in internet, there are a lot of emulator software. Some is a commercial software. The boss is a free one. Second is VMware. And the third is a Microsoft virtual machine. And on Linux or BSD system, we have QEMU. Basically, emulator is software environment for code execution in isolated environment. But there is a little bit different of the emulator concept compared to the emulator as I'm going to explain. The emulator in this project actually is a stand for the virtual buffer. This virtual buffer allows the execution part of the malware code in this buffer. And tracking execution path. This is different if you compare with static disassembly. Static disassembly, it cannot follow all branches of instruction. And the third is decryption of malware. This virtual buffer acts like generic attacker for decryptor of metamorphic and polymorphic viruses. And the last is acting like generic unpacking. And this idea is quite similar to the third one. But what is the result if we combine the emulator and disassembler? For example, IDA Pro able to interpret with a boss. You can execute the malware code using the IDA Pro and boss. This emulation is very powerful. You just execute the code, the malware code inside the boss, and it doesn't infect your local PC. Means that every malware code actually is running in the boss, and it doesn't infect your local PC, and you still can use the IDA Pro to trace step by step what is the malware doing. But the problem, this kind of combination actually is different from the today's topic, because how about the heuristic engine? If we can combine the heuristic engine together with this kind of idea, it will become a very powerful so-called malware detection toolkit. So this session I'm going to go through the design of the toolkit which implement the disassembler plus emulator with heuristic engine. In this process, in this project, we propose a toolkit that allows for automatic tracing and signature scanning of malware using heuristic engine with emulator plus disassembler The idea of this toolkit is execute part of the memory code within the virtual buffer or emulator and internally simulate what will happen by tracing the instruction. Every execution of the memory code will be scanning by heuristic engine based on signature. If the memory code matches with the one signature database, it will trigger the toolkit pure module, which will delete part of the code or totally delete the file. But this kind of pure method is still in the progress, and it doesn't work fine on Windows Vista and Windows 7 yet because of the user previous problem. Last is everyone loves to see GUI, so we come out with simple GUI which is written in Python. The core engine code in assembly language. And why assembly language? Why I choose assembly language? The first is the speed. Assembly language programs are generally the fastest program around. Second is speed. Assembly language programs are often the smallest. So it's very important when you run with a huge or very big various signature database. The engine is a key component of the toolkit in detecting malware. The engine has the following module. The first is auto unpacking module. Currently, it just supports the old version of UPH because my research now actually is concentrated in emulator. So I just come up the skeleton code for the auto unpacking module. Second is heuristic engine based on signature. Third is disassembler plus emulator. Last is the simple queue function. So this is the flowchart of the toolkit. Let me go through the heuristic engine design. The toolkit will start the information corrective portion. This portion is very important to correct all the important information of environment variables such as command parameter, prepare the drive path for scanning process, and start search the target file in the drive. In the search for file routine, the most important part of the code is process the file. When the code enters the process the file routine, it means that the toolkit already found the target file and start proceed to the next step. First, the toolkit will start to identify file types such as .com, .exe, or the sys file. Currently, the toolkit is just able to recognize the .exe file. Second, toolkit will start to read the file. Read in this process is save the original file attribute and copy the file into virtual buffer and identify the entry point inside the buffer. The next procedure is detect the packer. In this process, the toolkit uses the same heuristic engine which packer signature. This slide shows you the core of the heuristic engine. This heuristic engine used for packer detection and malware detection based on the signature database. The engine will find and blended an entry point of the target file and start the signature detection loop with signature database. For example, for packer detection, the comparison and pattern matching between the opcode will be compared with the packer signature database. If the scanning process detects the asterisk in the signature database, it will skip the number of bytes of the target file. If the heuristic scanning fails, the process will jump to the emulation section. So this is the detailed process of heuristic scanning in packer detection. First of all, is a definition. ECS is stands for the signature length. ECSI stands for the signature data. This portion actually is equal to various signature database. and the EDI is pointed to the virus.bit32.chris.4029 packet, which is packet using UTX. First, the load SB is an instruction load the first signature data, which is equal to 60 in hexadecimal format. There is a two pattern matching process in heuristic engine. The first pattern matching is engine will check whether the signature data equal to the asterisk. If failed, the process will jump to the detection compare. In detection compare routine, second pattern matching will start to compare the output malware, which is equal to value EDI, equal to packet signature data, which is equal to value EAX. If matched, the process will jump to the detection continue, increase the pointer of output malware and jump back to signature underscore detect underscore loop. The process will continue until the last value in packet signature database. Thus, in case if the data of signature database match to asterisk, the code will continue running without jump to detection compare. The following code will add the value of pointer to output malware, which is equal to EDI, which value after the asterisk. You can refer to the yellow line, which is equal to 7. The process will jump back to starting of the signature underscore detect underscore loop and start to do scanning between the new value of EDI and EAX. This is a detail of the process of heuristic scanning in malware detection. For this demo, I put one exe program, is so-called testfile.swiss cyberstorm, and let us assume this testfile.swiss cyberstorm is a malware, and this is part of the virus signature, which is I create for the testfile.swiss cyberstorm, and above is the test file output view by hex editor, and this part is equal to the heuristic engine. First, the load SB will load the first signature data, which is equal to BA in hexadecimal, and there is a two pattern matching process in this heuristic engine. The first pattern matching is the engine will check whether the signature data equal to asterisk. If failed, the process will directly jump to the detection underscore compare. In detection underscore compare routine, second pattern matching will start to compare output malware, which is equal to value EDI, to virus signature data, which is equal to value in register EAX. If matched, the process will jump to detection continue, increase the pointer of output malware, and jump back to signature underscore detect underscore loop. And this process will continue running until the last value of the virus signature database. Thus, in case if the data of signature database match to asterisk, the scanning process will continue running without jump to detection underscore compare. The following code will add the value of pointer to output malware, which is equal to EDI, which value after the asterisk, you can refer to the yellow line, which is equal to 2. And the process will jump back to the starting of the signature underscore detect underscore loop and start to do the scanning between the new value of EDI and EAX. And this is the result of the 2 gate. After doing the scanning on the file, test file.swiss cyberstorm in console and UI version. In this session, I would like to go through the detail, the design of emulator and disassembler. will set to 300 milliseconds. Why 300 milliseconds? This is a value of running time I set in the emulator. It means that the emulator is just executing 300 milliseconds. After 300 milliseconds, it will totally stop and jump back to the heuristic scanning. But it should be fine because the computer running process very fast. The first important component in emulator is disassembler. Disassembler will read the opcode malware in hexa format and understand it. For example, hexadecimal value 9C is equal to pushFD. If the disassembler fails and opcode malware cannot be recognized, the opcode will be categorized in unknown instruction and immediately stop the emulator process. If success, the process will jump back to next and execute the instruction in virtual buffer. After execution of the instruction, the process will jump back to heuristic engine and restart the heuristic scanning. This design is attacking the decryptor of the obfuscated malware. This slide will go through the detail of the disassembler and emulator. This is the example code of disassembler. Let's assume ECX is equal to the range of instruction, and TEMP is a temporary storage of EFLAGS register. The EFLAGS register is the status register in Intel x86 microprocessor that contains the current state of the processor. This assembler will doing the scanning of the input of opcode malware. In this example is equal to 9C. You can refer to the number 1. And the matching of the opcode will trigger the disassembler jump to emulator and execute in the virtual buffer. The right hand side is the emulator. Before the disassembler pass the value into emulator, first the emulator will save all the original value belong to EFLAGS and register EAX, EBX, ECX, and etc. And number 6 is pushAD is save the original register value of EAX, ECX, EDX, and pushFD is push the original of EFLAGS value to current state and pop into EAX, and from the EAX will save to the TEMP. The number 7 actually is a code to save the value of EFLAGS. Now the emulator define the EFLAGS value such as flag. You can refer to the number 8. This portion of the code is define the flag in the EFLAGS. And portion number 9 is define the IEGS plus 000 is equal to EAX, and IEGS plus 004 equal to ECX, and so on. And after the emulator is defined, the new value of the emulator, you will directly call the emulate_buffer. Refer to number 10. This is core engine of the emulator. The pushFD is the opcode of the malware, which we want to execute in virtual buffer. Before execute the opcode malware, the emulator sets the original value of ESP register and define the new value IEGS plus 016. This slide shows you the more detail of emulator. The opcode malware 9C is copied into the virtual buffer with the string of the opcode such as 89H, 25H, 8BH, 35H, and others. The execution of virtual buffer, which called emulate_buffer in previous slide, will execute the opcode and opcode malware. The emulator now sets the result of emulated EFLAG in flag value and register EAX, ECF, and so on into IGS plus 00, IGS plus 004 until IGS plus 0 to 8. You can refer to number 11 and number 12. Last, the emulator set the value of EFLAG and register EAX and EPX and other register to original value. The process of the program will jump back to heuristic for scanning. Conclusion is, the purpose of disassembler plus emulator is recognize the instruction and execute the opcode malware in virtual buffer. This is kind of instruction stalking. Follow the flow of instruction and attack the decryptor implemented by obfuscated malware. And currently, the toolkit support for console and GUI version. This slide shows you the example of console result after using toolkit to scan the C drive. And this is example of GUI version. It's quite ugly outlook, but it works okay. To simplify the flowchart of the toolkit in scanning malware, we propose to use Pyman. Pyman process stalking is cool and helps us to draw the graphic of the execution of our toolkit when scanning malware. For this purpose, we customize the Pyman framework and add in the new feature in Pyman Stalker with insert argument. Now we can use Pyman Stalker to trace how toolkit scanning the targeted directory. For this example, we try to use our toolkit to doing the scanning on the C drive virus directory. And this is the result of the Pyman Stalker. And my next plan is I'm going to add in the memory scan module, and the second is real-time monitoring module. The third is to enhance the unpacking module, because this is very important to reduce the size of virus mutated database. And the last is the framework GUI with Python. And this is my toolkit design and the output. Any question? Yes?
How do you code this malware that tries to detect that it's running in emulator? If you're having an emulator, you won't be perfect in all corner cases and all that. I mean, you'll have to cut corners, and often malware tries to detect that, and will follow a different path. That's it. How do you code with that?
It's because the emulator I propose is quite different if you compare with the malware which can detect the VMware. I know some malware actually they can use some code to detect. Okay, I'm in the VMware, I'm in the virtual machine, so I don't want to execute my malware. But actually, in this virtual buffer, it's just maybe I can show you my code engine of my emulator. So actually this is core engine of my virtual buffer. So you can see that the push FD actually is a stand for the one byte from malware code. Mean that first I will copy the malware into the virtual buffer and I select one byte from byte using the disassembler. And the disassembler will recognize the first byte is 9C equal to push FD. So the line number 10, the line push FD actually is malware, and the first and second line actually belong to my emulator, and the last three lines also is belong to my emulator code. So let's say the malware actually is equal to hop EAX. You just execute, you just replace the push FD equal to hop EAX. So this concept actually is very different if you compare the malware which is detect. Okay, I'm running in VMware. I don't want to execute myself. It's very different because this virtual buffer is kind of so-called instruction stopping. It just follow one byte for one byte, and I can recognize this output actually belong to hop EAX or maybe belong to push FD, and then I just execute it, and I grab the EIP, the next instruction, which is jump to any byte in my virtual buffer, and then I just follow the code. So hopefully, we already tested on like Paris, one of the very famous metamorphic virus. It just executes the code byte from byte, just follow the code. So this concept is really quite different if you compare with the sound you are talking about. Yeah.
But of course, if you malware makes some API calls or subroutines,
yeah,
be a bit more careful. You cannot just
execute the code. Yeah.
Really monitor.
Yeah. We just let it run, let it run in my virtual buffer. Because I copy this code, you just replace any bytecode. Is
instructional in this case if you have to manually.
Yes. Because every encryption, before you want to decrypt itself, because when malware is running and everything is copied to the memory, right? If this malware wants to decrypt itself, you need to use the instruction call. Maybe use instruction of push, hop, like UPX. You push everything to the memory, and you just run the code. And after that, you just pop everything, pop back everything.
Yeah. Also play around with hardware.
Yes.
Try to read files.
Yeah.
Graphic process.
Yes, correct.
What type of option? You need to emulate the whole hardware.
Yeah.
You cannot do that for all.
But I tested on all the metamorphic viruses.
What are the packages usually go into?
Yes, that's why I add in another module is packer detector. Why packer detector is, maybe I can draw something. So let's say you have 3 packer and 3 virus. If without unpacking module and emulator, you will equal to 9 signature, right? Because this is packer, this is virus. So if you implement 1 packer to pack 3 virus, so total out 3 packer, 3 virus, you need 9 signature. So let's say I have 3 packers and 3 virus. If my antivirus can recognize the packer and also unpack it, I just need 6 signatures, right? Correct? Because this is packer, this is virus. So my antivirus can unpack it, but I still can recognize, oh, this is the same virus code. So total up, I just need 6 signatures.
But I think you do realize a bit that the packer is also doing such nice things like memory modification stuff, but not, for instance, go to the internet and download something, you rely that the packer is doing the same stuff first, and malware is coming afterwards. So,
Yeah.
The hacker is somehow nice in a way.
Because some virus actually like total download, right? You will go to the internet to download something, right? But you won't download the things into my virtual buffer. Because currently I just follow the call and the push and hop. Yeah.
And
04x but only. Mean that that's why just now I mentioned why I set the emulator running time is equal to 300 milliseconds. If you set run the whole day, mean that you totally execute the code inside your buffer. First, you will crash my emulator. Second is you will you will execute something inside your virtual buffer and make your system, make your program crash. So that's why I define is this running 300 milliseconds.
We also have plans to use it later in the system where malware that will partial unpack, like a packet part is going away, unpacking the next part, executable. It's not always the way that there's an unpacking phase and the malware is like simple sometimes. It's like in a loop, the part is packed, executed, removed, and the next part is unpacked, executed, removed, or even virtual machine things like TV or things like that.
Because
with it, you have a virtual machine thing involved.
Because now currently the implementation of the instruction stocking is just follow the code. So I test it to attack the metamorphic and malware. This virus is a metamorphic virus. It's very famous and it's successful hack. But the problem is if you copy, if you execute, if you just increase the 300 milliseconds, you will totally crash your, how to say, if you define more than maybe 6 seconds or 60 seconds, you totally crash your virtual buffer. So I still struggle to tuning my system now because currently I have 3 portions. First is auto unpack. Second is heuristic. Third is emulator. So the first auto unpack and heuristic not found. I jump to emulator, execute some code, which is 300 milliseconds, and drop back to heuristic scanning. So we keep repeating. Yeah.
How do you handle self-modifying code and code that is right in place?
Pardon?
How do you handle self-modifying code?
Self-modified code. Currently, I didn't test my toolkit on this kind of virus. Yeah, maybe I will refer back to this virus because currently my target actually is obfuscated malware. This is stand for metamorphic and polymorphic viruses. Second is the packet malware. But metamorphic, if you use the disassembly, because every metamorphic viruses is set up to contain the disassembly engine. The second is you change the output, means that metamorphic viruses mean that after every infection, it will change the set of the code. So what I'm talking about the self-modifying is out of this topic.
And what's the general overhead for that? Like 5-10x? Right? What's the average overhead for that? How much do you pay to execute the unpack?
Currently just support the UPX.
No, what is the overhead of executing these single instructions one by one, doing the additional checks before and afterwards?
Yeah, it will crash my toolkit actually. Yeah. If you're doing you test on the sys file especially. If you're doing the testing on the sys file, because of the currently after Windows Vista and Windows 7, the sys file actually, if you want to access to the sys file, you need the higher user privilege. So my toolkit currently is just running on top of Ling 3 level. So it kind of will make a problem when I execute this toolkit on top of Windows 7 and Windows Vista. I think my next plan I need to count out the driver to let me to access to the higher user view rate through the driver.
Okay, I think we have to start
is debug, second is ODB, C is DDB, and the last one is a process monster. Yeah, it's correct. What is the primary rule of a debugger? First is monitoring the process. Second, as step through the code as it executes and disassemble in simple, variable format. And the third is extract assembly code from a program. And the last, extract. Yeah, 5% is in the vista. Okay, this is kind of push FD, this is the one part of my emulator code. This SSB code. The first is push 3 EFLAGS value.